Today we're starting a new unit about geologic history, and our first topic for today is called relative dating. Now, relative dating is not at all what you are thinking. It has nothing to do with dating your relatives. In this case, relative dating is the process of analyzing geologic features in terms of their ages without actually knowing the ages of the features. So for example, rock D is older than rock A. We don't know how old rock D actually is or how old rock A actually is. All we are saying is that rock D is older, rock A is younger. More examples of relative dating can be seen here. Here we have a man and a woman. If we were to relatively compare their heights, we would say that the man is taller than the woman. We're not telling you how tall either of them are. We just know that one person is taller, the other person is shorter. In another case, here we have a student and a teacher. The teacher is older than the student. We don't know how old each of the student and the teacher are, but we do know that the student is younger, the teacher is older. The same thing works with rocks. Here we have a picture of different rocks that have been piled up and formed on top of each other over a long period of time. And after today, you're going to be able to tell me which area of rocks are the oldest and which are the youngest. It doesn't matter how old they actually are. We just need to be able to identify the older ones from the younger ones. We're not going to be looking at actual layers of rocks, though in this class we're going to be looking at pictures of rocks. So here we have rock layers A, B, C, and D, and each rock layer has a fossil in them, and we're going to be able to analyze pictures just like this throughout the unit to determine where the old rocks are and where the young rocks are. So to start with today, we're going to go through two rules of relative dating. The first is formation of rock layers. So just to start, we need to know that the rock layers that you see in the pictures, if you're driving along the side of the highway in upstate New York, you're going to see all these different layers of rocks along the way. Those are mostly sedimentary rock layers that have formed as sediments have been deposited, that means dropped, and compacted over time in bodies of water. So all of the rocks that we're going to be analyzing, mostly within this unit, are going to be sedimentary rock layers. So here's an animation just to go through the formation of this. Here we have a representation of sea level. So we're showing a body of water. And over time, as sediments get deposited, dropped in the water, they form distinctive rock layers, one on top of the other. So it's very important to understand that these are sedimentary rock layers that we're working with here. So metamorphic and igneous rocks do not apply with what we're doing. So here's another image just showing you the formation of rock layers. The rocks in this image are all sedimentary and they're all piled on top of each other as they were deposited over a long period of time in a body of water. So another thing that's really important is sedimentary rocks have fossils. In each layer, A, B, C, and D, there's a distinct fossil found within each layer. And these fossils are there because as these rocks were forming at different time periods, the organisms that were living at that time or close to living at that time were able to be captured as fossils, which is really important because these provide clues to the past and what life was like on Earth at other time periods. It's important to note another reason how we can prove that these are sedimentary rock layers is because igneous rocks can have fossils. The lava that forms igneous rocks would burn a fossil. It wouldn't be able to save it. Same thing for metamorphic rocks. Those rocks form from heat and pressure. Heat and pressure would destroy a fossil. Sedimentary rock layers are the only types of rocks that can preserve fossils safely. Another rule is a really important one, and it's called superposition. The law of superposition states that in rock layers, the oldest layers are found at the bottom, while the youngest layers of rock are found at the top. So to go through this, rock layer D is the oldest, and we know this because it's at the bottom. This means this rock layer must have formed first. Rock layer A is closer to the top, and it tells you that it's the youngest. These rocks formed more recently. So back at this animation again, over time, rock layer 1 was deposited first, then 2, then 3, then 4, and then finally rock layer 5. So we can conclude from this information that rock layer 1 is the oldest rock layer because it's on the bottom. Rock layer 5 is the youngest. It formed more recently because it's on the top.